We are ready to do a couple of problems from ALEKS homework 3. We're going to start with calculating the pH of a buffer, and this is going to be similar to the examples that you have in your notes, but I'm going to go through two of them anyways, just to give you lots of practice. This problem says that we have a solution. It's giving us the concentration of this first component, dimethylamine, and then it's giving us the concentration of the other component, and it's giving us the Kb, and it wants us to calculate the pH of the solution. And because it's a buffer, and we know it's a buffer because there's a big hint right there, calculate the pH of the buffer. Because it's a buffer, we can use Henderson-Hasselbalch. pH equals pKa plus the log of the base over the acid. So a pretty common question that some students have when it comes to using Henderson-Hasselbalch is, can I use this equation and use the pKa when the problem is telling me that it is a weak base buffer? Like, wouldn't this be for an acid, and am I allowed to use the equation anyways, even though it's a base? And yes, for sure, you definitely are allowed to use the Henderson-Hasselbalch in this form for either an acid or a base. The only thing that you have to keep in mind is that the Henderson-Hasselbalch does require you to use the pKa, whether you're dealing with an acid or a base. So if you're dealing with a base and you're given Kb, that just means you are going to have to convert it to pKa, but you can still use it. It's allowed. If you're looking on the internet at other resources, you might see the Henderson-Hasselbalch equation expressed differently, expressed in terms of pKb, or maybe with the base and the acid flip-flopped, things like that. There is more than one way to write this equation, but for the sake of consistency, we're always going to use it the exact same way. So for this problem, we will know the pKa. We don't know it now, but we will know it. And we do have a concentration of a base and a concentration of an acid. So we have everything we need to get plugged into this problem. We just need to start by converting our Kb to a pKa. So the way that I like to do that is to first calculate the pKb from the negative log of the Kb. The negative log of the Kb is 5.4 times 10 to the minus 4. And that is negative log of 5.4 times 10 to the minus 4 is 3.26. I'm going to keep a few decimal places on there so I can try to keep ALEKS happy. And then also the relationship that we have between pKa and pKb. pKa plus pKb is 14. So that means the pKa equals 14 minus pKb. 14 minus 3.268. Our pKa is 10.732. So we can plug that in up here, 10.732 plus log. Now we're ready for the next part. We need to know the concentration of our base and the concentration of our acid. Remember, I told you that the acid will have one more hydrogen than the base because it is our H plus donor, so the acid is going to have an extra hydrogen on it, and that's how we're going to find the acid. This guy over here has got 3, 6, 7 hydrogens, and this guy over here has got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. This one has the extra hydrogen, so this is our acid. And this is our base. Now that we know which is which, the concentration of our base is 0.46 molar. The concentration of our acid is 0.095 molar. And now we can just crunch the numbers on that. 0.46 divided by 0.095. Take the log of that and add it to 10.732. So I am getting 11.417. ALEKS says 2 decimal places, so that means I want 11.42. Let's see how it likes that. 11.42. And so let's go ahead and do another one so that you've got a couple of examples. This one, it says we have, again, we're being asked to calculate the pH. We have a Ka. We have concentration of one substance and concentration of our second substance. And because it is a buffer, we want to use Henderson-Hasselbalch. pH equals pKa plus the log of the concentration of the base over the concentration of the acid. So first, let's find out our pKa. We have a Ka this time, so the pKa is going to be the negative log of the Ka, which is the negative log of 6.3 times 10 to the minus 5, which is 4.201. And I'm keeping some extra decimal places on there until I get to the very end. So 4.201, our pKa, plus the log of the concentration of the base over the acid. So we've got to figure out which is the base and which is the acid. The benzoic acid has 1 plus 5. That has 6 hydrogens. Oh, and it says it's an acid. It's probably our acid. I didn't even look at that. The other one, sodium benzoate, has 5 hydrogens. The one with the extra hydrogens is the acid. The concentration of our base, now that we know which is which, the concentration of our base is 0.32. The concentration of our acid is 0.35, and we are ready to solve this. 0.32 divided by 0.35. Take the log and then add that to 0.4021. We get a pH of 4.216. No, I don't know what I did there. 4.162. To 2 decimal places, that is going to be 4.16.